Hello everyone. In this video, we will understand solar storms. Recently, Earth was hit by a severe solar storms which was much stronger than the expected intensity. United States National Ocean and Atmospheric Administration, that is NOAA, it gave this geomagnetic storm a severity of G4, which is the second highest grade possible. It is also said that this has been the strongest storm in last 6 years. Now let us understand what this solar storm is in details. So solar storms are intense bursts of energy from the sun that can cause disruptions in Earth's magnetic field and our technological system. To understand solar storms in detail, we need to go through a few concepts. The very first concept here is corona. The sun's corona is the outermost layer of its atmosphere consisting of extremely hot and ionized gas. It is visible during a total solar eclipse as a halo of bright white light surrounding the darkened disk of the sun. There is one more concept which we need to go through, that is solar wind. Solar wind is a stream of charged particles, mainly electrons and protons, flowing from the sun's corona into space. It plays an important role in shaping and interacting with Earth's magnetosphere and is also responsible for phenomena such as auroras and comet tails. So here in this picture you can see that there is this particular portion, fine, there is sun and there is this photosphere of the sun, and from the photosphere of the sun there is a continuous flow of charged particles towards the outer parts of the sun. Now this flow of charged particles is nothing but solar wind. Now let us understand one more concept, that is coronal mass ejection. Now coronal mass ejection is a massive burst of solar wind and magnetic fields rising above the solar corona and being released into the space. The CMEs often look like huge twisted rope, as you can very well see in these graphics. It is also called as flux rope by scientists. Now when it comes to CMEs, the frequency of CMEs vary with the solar cycle. So solar cycle is a 11-year cycle where there is some solar minimum and solar maximum. At solar minimum, there would be less intense heat from the sun. At maximum, obviously there would be a lot of heat which is radiated towards various planets. Now at solar minimum we observe about one coronal mass ejection a week, and when it comes to solar maximum we observe on an average 2 to 3 coronal mass ejections per day. So there is a huge difference between solar minimum and solar maximum. Now let us see what this whole process looks like. So if you can see in this particular graphics, we have some material which is coming out of the corona of the sun. So there is a continuous process of solar winds, that is obvious, which we have already seen in the last graphics. This particular part, this is forming solar winds, but in these solar winds there is also the release of coronal mass, that is nothing but, as we have already seen, ionized gases would be there, there would be charged particles, there would be plasma, and all this is thrown towards various planets in the solar system. Overall effect, if you see, there could be many effects we would be experiencing in this particular part, but before we go into these effects, let us understand what exactly this coronal mass ejection is a result of. So when we go through the causes of coronal mass ejection, we do not know the causes of coronal mass ejection, but it is generally thought that CMEs are caused by destabilization of large-scale magnetic structures in the corona and the resulting reconfiguration of the coronal magnetic field. So overall impact, we already have seen continuous flow of solar winds, and adding to that there would be coronal mass ejection during certain periods. And when there is a coronal mass ejection during certain periods, it would intensify solar winds and the hazards associated with it. Now let us understand what effects do we see as a result of solar storm. Now we are only talking about the effects of solar storm. We are not specifically talking about the coronal mass ejection. Coronal mass ejection is nothing but intensified event of solar storms, we can say. The very first and most important effect we see, that is aurora. Now what is aurora? Aurora is also known as polar light. So polar light is a light which is observed on the northern pole and the southern pole. The light which is observed on the northern pole is called as aurora borealis, and the light which is observed on the southern pole is called as aurora australis. This is created as a result of the solar storm or the charged particles from the solar storm and Earth's magnetic field. The charged particles from the solar wind or solar storm, they interact with Earth's magnetic field and it generates certain light which is called as polar light observed on the both of the poles. Another important effect which we often observe, but only in the case of intense solar winds or intense solar storms, which is the case recently. So there could be a failure of power grids because power grids are mostly run by electronic mechanisms, and there is flow of charged particles in the atmosphere when there is coronal mass ejection from the corona of the sun, and this would ultimately lead to the tripping of power grids. A few other effects, if we talk about, satellite disruption is one more effect we need to observe here, because in the outer space or near the lower earth orbit, you will have a lot of charged particles coming out of the sun when there is a coronal mass ejection or any intense solar storm. So it would affect satellite, it would deflect satellites from, it could deflect satellites from their orbits. It also affects satellites, micro controllers or the electronic components, and ultimately it would result into communication failure. Other impacts, if we want to talk about, would be increased atmospheric drag. There could be some health impact. There is overall impact of solar storms on the biosphere of the earth. Communication disruption, as we already have talked about in satellite disruption, and there could be radiation exposure. So these are overall effects of solar storm. So that was all about solar storm. But before we wind up, I expect you to comment in the comment box regarding one important event of solar storms, which is called as Carrington event. So please mention when Carrington event was occurred and what all effect of Carrington event was there. So see you again in some other video. Thank you.